Heart rate is equal to the blood flow rate over the amount or volume of blood in every beat. The volume of blood per beat has been found to scale in direct proportion to an animal's mass, so that's just m. And the blood flow rate? Well, remember that metabolism is all about how nutrients get distributed around the body. So most biologists agree metabolic rate and blood flow rate are directly proportional to one another. So heart rate should scale as metabolic rate over mass. Swapping in the scaling law Kleiber had found, that gives us m to the minus 1/4. Meaning bigger animals should have slower heartbeats than smaller ones. And this is exactly what we observe in nature. The world's smallest mammal, the Etruscan shrew, has an extraordinary heart rate of 1,200 beats per minute. That's 20 beats per second. Whereas the biggest land mammal, the African bush elephant, has a typical heart rate of only 30 beats per minute. And we can do something similar for lifespan. One of the leading theories is that an animal's lifespan is based on the accumulation of metabolic damage. That is, as each chunk of tissue in an organism processes nutrients over time, this causes damage to accumulate. And that, over time, causes the animal to die. So the rate at which an animal accumulates damage is its metabolic rate per unit of mass, and its lifespan should be the inverse of that rate. If damage accumulates faster, it dies sooner. If it accumulates slower, it lives longer. So lifespan is proportional to m over b, or substituting in Kleiber's law, m to the 1/4. So lifespan should increase with mass, and you do see this in nature. A shrew only lives for 1 to 2 years in the wild, while the mighty African elephant can live up to 70 years. So if you're a small mammal, you have many heartbeats per minute, but you live a relatively short life. Conversely, if you're a larger mammal, your heart beats much slower and you live a lot longer.
So it's the, live fast and burn out and, die young, right? Or spend it frugally and live a really long life.
But you might have also noticed something else. Heart rate scales as b over m, so it equals b over m times some constant. And lifespan scales as m over b. They're inverses of each other. They scale in equal and opposite directions. Now, the total number of heartbeats in an animal's life is just the heart rate multiplied by the lifespan. So when you multiply these two terms, they cancel out, leaving you with just a constant. So that suggests that no matter what mammal you're talking about, it should have roughly the same number of heartbeats. You can find that number by just plugging in some examples. Let's start with the Etruscan shrew. The shrew's 1,200 beats per minute multiplied by a lifespan of around 1.5 years gives you around 950 million heartbeats in the course of the shrew's life. Meanwhile, an African elephant's 30 beats per minute multiplied by a lifespan of around 65 years gives you a little over 1 billion heartbeats. And we could keep going. But for nearly every mammal you look at, you keep landing at the same figure of around 1 billion heartbeats. This is why nearly every mammal, from a tiny field mouse to a gazelle, from a cheetah to a hippopotamus, they all get around 1 billion heartbeats between the day they're born and the day they die. But there is one major outlier, one mammal that gets significantly more than 1 billion heartbeats, and that is us, humans.